Good morning everyone, and welcome back to the CNC Techniques channel. Today we will be working exclusively in manual. Guide focusing on this valve, specifically on creating the outer profile. If I see that the video isn't too long, I might add the two holes and the front groove later, but the interesting part remains the profiling. The part you see in black is the drawing provided by the client, and the part you see in green are the dimensions I had to calculate to find the references to give to manual guide. Calculating is a big word. I took the DWG that the client gave me and asked him for the dimensions. Fortunately, we have some technological tools on our side, so I inserted a raw material with a diameter of 125. You can see that the maximum width is 122. With the pre-drilled hole already done at 65 high and 12.5, and with my outer plane set to the same level as the 0 point of the self-centering chuck, I enable the motorized axis to 0, set axis 0, and call a tool offset that corresponds to a candle cutter with a diameter of 10. I set my cutting parameters and set feed rate in millimeters per minute. I already insert a nice M30 so that I can do my simulations as I go along. We're all set, and I'm going to call up the first contouring cycle. These are the turning cycles. We need a milling cycle. Contouring, wall, roughing the outer part, but we will use it since the cutter can work very well in one go. So the depth of our machining, as we said, is 12.5, but since we're working in the air, we'll set it to 13 millimeters. I remind you that the translation here is incorrect. We need to look at the lateral excess material. We start from a raw piece of 125. And the diameter here is 92, which means that the lateral excess material we need to remove before we start profiling our shape will be 92. Minus 125, so 25, 35 minus 2, 33 millimeters. Diameter, we make 34, 17 millimeters on the radius, so the excess metal at the maximum point is 17 millimeters. I always recommend increasing the radial cutting depth a little. Engage 10 mm end mill at half diameter. Axial depth 7 for 2 passes. Adjust during entry. Axial cutting depth. You haven't seen anything yet. How deep do we want to work with? Our end mill. Let's set it to 7 so we can handle it in 2 passes. Then, during the entry phase of the machining, all these parameters can be adjusted. What matters to us is to understand the reasons behind these choices. Today, I'm in the mood to work. I said we wouldn't do the finishing, but let's do it. Let's leave 1 millimeter of excess material on the side and practically nothing on the bottom because, as you can see, there's no bottom in this case. 500 millimeter per minute for the feed rate is a bit nonsensical for us because we told the machine to engage a maximum of L, so 5. I didn't hit enter on that, but let's go with 7. Today I feel like working. I said that we do not do the finishing instead. Let's do it. Let's leave a millimeter of excess metal on the side and practically nothing on the bottom, because as you can see, the bottom in this case, there is no 500 millimeters per minute of advance, 500 millimeters per minute of advance from the full, which for us is nonsense because we will not do it, as we have told the machine to use maximum L, therefore 5. I didn't press enter on this one, 7. And the entry speed is 50 millinuclear per minute. This particular value, this box, is not adjustable. We want to work in a coordinated manner and enter tangentially to the piece. In this case, it's better to enter vertically and exit vertically, maintaining safety distances of 5 millimeters I always recommend setting the retract distance to be greater than the cutting depth. Let's insert our cycle. And now, let's tell it, okay, here's our cycle. We want to do a free in the XC plane. So the machine asks us to make a drawing. In the original drawing, there wasn't a starting perimeter dimension, except for this one, which was known, but I had to start with a radius and close with a radius. As I mentioned in the previous tutorial, my shape needs to be closed, so I need to give it a known starting point. In this case, 57.7 and 7.86. That's perfect. So the starting point is approximately 57.7. Initially with radial measurements of about 7.86 from C. We need to draw our piece with a base of 7.86 Z, starting from plane 0, as we said, for a depth of 13 mm. Okay, we have the first point. From here, we start drawing our shape. So, a line, inclined upwards. I enter these coordinates, 32.2 and 33.48. 33.48. I hit send. I don't provide the angle because 2 coordinates are enough. And you can see that we've made our first line. Now, we focus on inserting the first arc. The arc we will execute in a counterclockwise direction. Will have coordinates opposite to x, so minus 32.2. The same C, which is this one. So 33.48 and the circle has a precisely measured radius of 48 millimeters. Okay, here's our radius. From here, a line. Inclined, downwards, coordinates, opposite, in x. So, minus 57.7. The same, C. So 786, okay. Another radius, still, in the same direction. So, here, we will always go in the same way. X, that is approximately minus 57.7. Minus 57.7 will gradually start to change direction towards C. So C, minus 7.86, known parameter of 11 millimeters. Okay, here it is. You see that our figure is clearly taking shape. And we continue with our line, inclined to the right. So, minus 32.2, as you can see. Minus, because it stays in the same direction, 7.86. Okay, did I make a mistake? I made a mistake, no problem. Just make a correction. It should have been down to the right. Sure, sorry, minus 57.7. It's right. In this line, it doesn't want to be constructed. In fact, so I need to get here. It's the opposite of this minus 33.48. Allow me, for rare, is human. And let's start thinking arc always in a counterclockwise direction. So, x. Let's go back to the positive side of 32.2. C minus 33.48. 33.48. and radius again 48. Send, okay, line to the right and upwards. So x 57.7, c minus 7.86. Quattro 7.86 x2 3 radius. At this point, it's time to close our figure with another arc, still in the same direction, which will end at the point where our figure started, strictly, with just 1/100th of a difference between the starting point and the final point will generate an error. Okay, and here our figure is complete. So we create it in a subroutine that we will call 0, 0, 11. It's essentially important that in the subroutines there is initially an O and 4 digits for the name of the figure, rhombus. Then it's up to you, you know. Okay, so automatically, instead of having to input the entire figure, it inserts the rhombus figure for me. At this point I can insert a nice contouring and lateral finishing, cycle wear. S is the over metal, which we called S1. K is the over metal that I will eventually leave for a super finishing, and we go to insert 0. A finishing pass. Feeds are inserted. Particular, always vertical, and it still takes all the data I had entered before. It doesn't ask me for the depth because it takes it directly from what I entered in the figure. Let's insert the subroutine for the rhombus. Let's do a simulation to see if what we've done is correct. Of course, at this point, nothing was stopping me from inserting a cutter with a greater sharpness and different cutting data to achieve a somewhat special finish. At this moment, however, I have a doubt. I have the doubt that I may have incorrectly entered the machining height in my subroutine. Now from here, I can no longer modify it as we did in the previous tutorials. Do I have to open P012, edit it, close it, and go back to P011? Or is there a shortcut? The shortcut I wanted to explain is that I automatically enable the soft key Edit Background. Edit Background allows me to keep my 00 or 11 called as the main program, and so also the program that I will then work on from Edit. And it allows me to modify any other program in Edit Background, in this case on both. I go to any of the blocks in the figure, press the Edit button, and check my starting point. Edit. In my starting point, there's the height that we need to work on, which always has to be entered, with the machining sign, meaning I have to remove at Z13, which is this, the famous 12.5 that I made a bit, more than necessary. I give it my OK and tell it to create it for me. Creation of a subprogram. I give it my OK and tell it to create it for me. Creation of a subprogram. No, absolutely not. In this case, I need to modify the current program. Okay? And as you can see, my current program now has a 13. If I go back to Edit, I'm taken back to the main program. It's a small shortcut. The importance of this shortcut is due to the fact that if we open it in Edit and then forget, we end up automatically executing the subprogram. That's why edit background is very important when working with subprograms. Let's go to simulation. And we click on our piece. You can see that it has been executed correctly. If I set it to single block here, you can see just barely that. I'm taking off 1 millimeter. Here you can see it clearly. Since I've used the same cutter, it doesn't change color. Here you can see it clearly. Having used the same cutter, it doesn't change color. This is my finish done in one piece. I restart the start, which is always nice. This is our machining. Perfect. I would say that the contouring of our valve has turned out quite well. At this point, let's insert a tool that calls for a drill. I remember from memory that in my tool table T0232, it's a 3 and 4 drill. So, with a radius, meaning a drill, diameter of 6.8. Let's update the speeds and start inserting. Our milling. Cycle. More. Specifically the drilling. Cycle. So, let's select it. We need to make a hole. That's about 14 mm. Deep plus 2 mm for spacing. We'll set the chip breaker to 5 mm, which is fine. The return mode is also fine, which is basically where the bit goes when it returns. For the retract point, we'll set it to 3 mm. The cutting depth needs to be enough for the bit to come out, so at least 15 mm. So let's make sure we don't make the same mistake as before. A safety distance of 3 mm is enough, and we'll set the feed rate to FEO port 12, giving it a half-second pause during the chip breaking, if we don't want to change the feed rate. We can just take FEO point 12 and put it here, and here for the bit. Then we can set the values we want. At this point, the bit will enter at 0.12 and exit at 0.12. And that's it, no more to discuss. We insert the cycle, and it asks us, what do you want to do? I want to do a front drilling on the C-axis at points on an arc, because we have the diameter of the two holes that are equidistant from the center at 50 mm. Perfect. X-axis position at a radius of 50. Base Z position at 0, because we're starting from here to drill, and the graphic helps us with the angle. We'll set it to an angle of 0 degrees, and then in the graphic we'll see if the two holes are made here, and here, or here, and here. If needed, we'll make the necessary adjustments. We insert the cycle and go to simulate. I have my wife on the phone. I hope you can't hear her. Blah, 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 because with the door closed you can hear. Here are our holes, made perfectly. With the same cycle you can add a countersink of 1 or 2 millimeters deep. That doesn't complicate things. Same cycle, same modus operandi. Instead of making a through depth, you make a lesser depth of 1 millimeter. There's even, if I remember correctly, the cycle dedicated to, let's take a look, to countersinking, and that's it. And in theory, I've always done countersinks in ISO. No, tapping, reaming, centering, use a drilling technique and make it shallow. Let me see if there's anything else. So if you want to do a countersink as well, you need to set the machine up properly, drill the hole, and instead of making a through hole, you make it 1 millimeter or 1.5 millimeters deep. Alright, I'm going to stop here because otherwise the video will get too long and hard to sit through. I hope what I showed you today was of interest. If so, as always, a like and a subscription to the channel would be great. If possible, share the video on your social media, and if you didn't like it, just pretend you didn't see it. Thank you for your attention, and I look forward to seeing you in the next tutorial.